Well, hi and welcome to this talk about Extending Redux in the server side. So my name is Nacho Martin. My name is Nacho Martin. I'm Spanish, but I actually live not so far from here in Munich. I work in a company called Minus, and we make applications for customers. We are really happy with React and React Native. So happy that we organize a conference in September in southeast of Spain. So we know how hard it is to organize this thing. So thank you to the organizers. And well, we are going to talk a lot about Redux here. So let's start with a very short introduction to Redux in case some of you are not so familiar with it. I really like a lot this diagram of Redux because it really shows how it works and all the pieces, how they connect it together, but also shows this circular flow that we are going to see a lot during this talk. So how does it work? When something happens, like the user clicks a button, then we describe this event as an action, like description of what has happened. And then we have a reducer that will take this action and the current state, the current version of the state, and will produce a new version of the state. And then the views are connected to this new version of the state and will re-render a new representation of the new state. So directly from their documentation, there are three main points in Redux. One of them is that there is a single state, not several states, not several stores scattered in your application, connected to different components, but only a single store for the whole application. Then you can change this state by dispatching actions. So not by manipulating it directly, like with a setter or something like that, but dispatching actions that describe something that has happened. And then to actually do this new version of the state, we have what we call reducers. These reducers are pure functions that have only one goal, which is take the current action, so the current version of the state, and the action that has been produced, and produce a new version of the state. So at a given point, you all can always think about your current state as a consequence of the initial state you have and all the actions that have been produced, right? So this was the short introduction of Redux, and then let's see what are we going to talk about. So we're going to talk about a particular perspective, and that is useful, that has been useful for model certain problems. So at the end, we will see how to extend this, maybe your case is not my case, to a bigger set of problems, right? But this has started for us as from a particular problem that I think is very good to show this perspective. Right? And also because I think it's very important to have always in mind that you are always solving a certain problem. So you have to find the right ideas that fit really with your problem. Right? Not, so you always have to do something concrete, not something general. This links with this topic, general topic of the map and the territory. This is a topic not only in computer science, but like in the world, in the general world, where well, there you have territory, which is reality, and then you have a map that is the representation of reality. And how do they interact? You have these ideas and paradigms and metaphors that you apply. What is the relationship with reality? There is a lot of stuff that is super interesting about this. There is also a small part, well, a small, medium size of it, that I'm not so into it. It is when some people ask you like to go to the mirror and tell to yourself, I'm rich, I'm super rich, then trying like to bend reality. Like, because I changed my representation, I'm not really into this thing. But, and also I think that in computer science, we don't need to go to this so far. Because in computer science, we have a very different problem, or slightly different problem. It's not map and territory, it's rather the plan and territory situation, where we are not asked to build a representation of reality, but we are asked to actually build pieces of reality. So in this case, whatever we have in our minds, whatever the paradigms, ideas, we have words for them or not, they will have a direct impact in what we are going to build. Especially if we work with other people, like we have a plan and you distribute copies of this plan, this will, of course, have a direct influence in whatever is built at the end. And there are some paradigms that sometimes, because they have been super useful for certain problems, we try to apply them like every time we have because of inertia, right? This worked last time, so let's try it again. And for instance, and sometimes we kind of overstretch these paradigms, like a little bit. Like for instance, there is this one that is a typical case because it has been so successful that sometimes we kind of overstretch it. Is this CRUD paradigm when, of course, because you have a database that is has these operations, create, read, update, and delete, and I kind of have the idea of how it works. It's simple, so can I just apply it to everything in my program, like everything can have this idea, single idea? Yes, well, I can try. So I have this RESTful API, has these 4 operations. I can match them, so it can work. And then if we think about our problem, like with this idea every time, how will it look at the end? Our project will look like, of course, tables will look like our database. And this is like very good for some situations. Like some problems are super well modeled by this. Like for instance, admin panels, super well modeled. Or maybe a blog engine, okay? Or maybe classified ads can be. I mean, lots of problems can be very well modeled by this, but sometimes, because this paradigm is so useful, sometimes we try to squeeze new problem into it, and you find yourself like you are cutting corners all the time, and it's a lot of friction there. This is not the only paradigm that I feel has been overstretched. There are others, like, for instance, one that is closer to our problem, which I don't know the name for it, but I have a name for it. I call this the chat tutorial paradigm, which is what happens when you want to do something like in real time, like you want to something with WebSockets. I feel I have this kind of real-time communication, so let's go. I want to build a prototype. Let's see how this works. And then you go to the library, or for instance, Socket.io, or one of the libraries of WebSockets, which is a transport library. And they always have this same first tutorial, which is a great tutorial to explain how a transport library works. I know because even I wrote one once. It always goes like this. There is a chat. Someone types a message, clicks and send. And then there is an event that has been emitted, new message. And then the server is listening to these events and will broadcast these events to whoever is subscribed to. Like different libraries call this to a topic or to a room or to a channel. Is the same concept. They subscribe, for instance, to this chat room. So every client will receive this event, and it will update its state, right? Its local state of client state. So this is very nice tutorial because you see how it works in like Socket.io, and you say, OK, now I think I can start doing my prototype. I really can. I feel confident with this. But probably your situation is not, you are not going to build a chat. And even if it's a chat, the next thing that will happen, very likely, is that you want to have some kind of state also in the server, right? So maybe we want, for instance, in a chat to store the log. So when user is disconnected, you show them like the last messages. Or maybe your problem is much more complex or it's different, so you will have very likely state in the server and a state in the client. It's something the library doesn't care about. It's like it's up to you. But then if you are basing your solution in this, which is the tutorial for how to use a messaging platform, a messaging library, how will the project look like? Well, look like messages everywhere. Like everything will be a message, because of course you are basing your idea in how a messaging library works. So maybe some problems fit very well, because they are very more related to messages, and others not so much. In our particular case study, we have found this family of problems quite often in the last years. Like, for instance, one of the projects we have to deal with this was building a platform for games, like simple games, like card games or domino or quizzes, like simple games I play with my grandparent in holidays, for instance, just spare time. And the goal of this project, like the focus, is to deliver them, like to build quite a lot of them. So not to stop finding, if you can have a very nice solution for one, like with as less friction as possible, to really deliver. And then there is another one, is different. We're building a platform for dietitians for some years. It's a long-term project. And then we have there's a section so that they can drag and drop recipes, and they see alerts if there are allergies, or they see the nutritional components and so on. And this grew in users, and at some point, universities wanted to use for their students to teach them how to do diets. And then they required it. They said we wanted this to be collaborative. So when a student does something, the others can see it in real time, like kind of like Trello does. So these family of problems have always the same things, 2 points in common. There are multiple users manipulating the same resource, and they need to be notified in real time of the changes. So whenever there is a change, they need to be, they are subscribed to them. So let's see how to work with this. Like, we know how to work with Socket.io, so we want to build a prototype, right? Like, even in a simple case, like a multiplayer quiz game, how will it evolve? How will it work? Like we have, for instance, this is multiplayer quiz game, we show an answer, a question to everyone, and a set of answers. And the users have to pick, they pick one of the answers, and they see some scores. There's one winner, there's one loser, someone wins, someone loses, this kind of stuff. So the client sends an event describing what has happened, answer, I just pick this answer, and the server has to do quite a lot of things, even if this simple example has to do quite a lot of things to come up with a new version of the state. Is the answer correct? Are we waiting for someone, or is everyone done? There's a timeout for the next question, we show the next question, or we show the scores, it's the game over. So it will produce a series of events. So for instance, which answer has been picked? So even in this case, for instance, that is almost the same event, like it's an answer, the events will be typically different. They are not exactly the same event. The server typically knows much more, or provides extra information, knows which answers are correct, for instance. It is in almost every situation. So the events are the same, but not exactly the same. Or you have, with this, for instance, the client will mark the answer as selected, so updates its own state. We receive more events, like new question, so we show this question, or new scores, we show an animation with the new scores, and so on. So then we start adding events, and even the simplest application has lots of events at the end. Lots of things can happen. And at the end, you feel like you quickly realize that you have 2 vocabularies of events that are slightly the same because they are related to the same problem, luckily, and 2 representations of the state that are slightly similar but not the same. The server typically has more information. And if you don't force them to be the same, they won't be, naturally. So if you have 2 vocabularies of events and 2 representations of the state, you have 2 ways of calculating the state. And at the end, you are doing 2 applications in the sense of building the logic. And this was like double of the friction we expected. Like we expected it to be much more simple. And it was like every time you have to add an event, it was like, OK, you have to add it 2 times. Let's wait for the backend and the front end. And maybe, for instance, you are working in the front end and you find a problem in the backend and you want to have a look because maybe it's simple to solve. And then you find that the code, well, is similar, but not exactly what you are doing. So you, better not to touch it. It was more annoying than should be, except for a situation. It was not even an event, but there was a situation where everything was good without friction. And so we were like kind of waiting for it to happen, like rooting for it. This was the situation. When the user was disconnected, it was the perfect time for us. Like, oh, this is fine, wonderful. Because when the user is disconnected, you can just say, OK, I didn't receive the events. I don't know even how many I missed. So can you just send me, like, as an exception, the state at this particular moment? And the server will say, OK, as an exception, I just give you the state. And this comes with much less friction. This was much simpler to implement. So after doing this situation, we were doing more events and more events. And we were kind of missing the disconnection. We were kind of, can we just pretend that the user has been disconnected? Can we just disconnect him? So when you are kind of waiting for this to happen, like your situation is when things are disconnected and so on, it's like when you feel maybe there is enough friction here. Like maybe something is not exactly fitting what I was expecting to happen. Something saying me I'm not applying the right model. So at this moment, the solution comes naturally. So instead, what we are doing, we can just send an event, and the server will calculate its state, and will send not an event, but a piece of state back to whoever is subscribed. So we have, again, the circular flow of events a kind of reducer that produces a new version of the state and sending the state back to there. So kind of, we are seeing here, start seeing the same pattern as Redux. This means also we have to do only the application once. And in words, it will be now a part of the client's Redux store state is in the server. There is still one single source of truth, but part of it is in the server. And it's only a part because normally, typically, you have more state, like local things for the client, like, for instance, the user preferences that it has, or has the sound activated, or something like that doesn't need to live in the server. But the stuff that is being manipulated by several users will go into the server. And then the server still will have more information, but will keep this, like this zone that is going to be just copied, or maybe with a div, plugged directly into the client. The client can change this state not by sending actions, but by sending events, which are more or less the same thing. You send immutable events with WebSockets, and they will have an impact in the state. And then the server will push slices of the server, of the state, to whoever is subscribed. So they will just update their views automatically when someone touches these resources. And this then feels, this moment, like since we have part of our Redux store state in the server, now it feels like we are stretching what we have to include the backend, so to make it part of this flow. Right? Instead of having like a kind of a wall where you throw balls and you receive other balls that are kind of similar, you kind of include the backend, so it plays very well with the frontend. So let's see. This was like explanation, but let's see, can we build this, or what tools we have to do this kind of work? Are we restricted to a particular library or to a particular language or not? What can we use? Well, the most direct thing to do, at least to show the idea, is if we have JavaScript and we have Redux, can we just use JavaScript and Redux in the server side? Well, of course we can. This can be a possibility. This is not what we did at the end, but it's possible, and it's the most direct way to show this. So if we had this is the diagram of Redux with views, actions, reducers, state, and this circular flow. Now we have a separated another store in the server, right? So it will be this one. There are more arrows, but it's like the same thing. Right? Have events, and then reducers and the state. So let's do these arrows. Like, for instance, this one. We have a view, and then something happens, and then we produce an event. Well, I have to say, in this case, we are doing a tic-tac-toe game that I think is the simplest thing to showcase this problem. And this will, just to show the idea, this will be us playing against the server. So not against other player, but will be the server itself which is manipulating the state. Because otherwise, we have to show as well how to negotiate if the two players are ready and so on, which is kind of boring part and the departure from the problem, or the idea. But so here we just play against a random player. So the single player, sends an event. We like this. Here we use sagas for this, like to organize WebSockets and so on. Typically use sagas. But here, just to fit in one slide, we'll just say that when user clicks in a tile, it will emit one event with WebSockets. And then now we need from the server to capture this event and dispatch an action to our store. Right? So in Socket.io, for instance, it's like this. We get an event, and we dispatch an action. It's like turning an event into an action is the same thing, more or less, just wiring, connecting wires. We have these two events here, like user can play, or user can say, OK, I want to play again. I reset to the initial state. And then with this action, dispatch, we need to do our reducers in the server. So in this case, for instance, reset will return the initial state, and the play doesn't matter unless you are very into tic-tac-toe. It doesn't matter the particular implementation of this tic-tac-toe game, but basically, yes, we are computing a new version of the state based on whoever move and the artificial dampness we have. And then with this, they have the state in the server, and we need to push it as soon as there are new changes. Right? So Normally in React, React does it like there is this library, React Connect, that does this kind of thing for us. But then here we have to do it manually. Basically, we can be super smart about this code with selectors and doing, but basically, what you can do is just to subscribe manually to changes and then emit a game update state. It's in this left side. So subscribe to changes and emit an event, right, with the state. Then in the client, we need to be listening to this event and dispatch an action. Again, wires, always wires between events and actions. And then we have these reducers in the client side that will be much easier because they only need to, they will receive always the same event in this kind. Say I receive a state and I want to plug it into the store. So it's simple. I receive this event and I just copy it to produce a new version of the state that is the same as I have in the server. Or, update game, Okay, the game is the action creator, and then you have the reducer, Then, there is one arrow left, which is we need the views actually to be connected to this, of course, to this store to reflect the changes. Then we do this in React with connect, right? To connect these slices of the state with our views. And with this, that will be it. I mean, we can, of course, use the same library, and it will feel like actually we are using Redux because we are using Redux. I mean, it will feel like we are actually using the same pattern because we actually are using the same pattern because we are using the same library. So it's, of course, very direct. So are we restricted to a particular library or language, or can we use other stuff? Like, for instance, can we use Elixir? Elixir, it is actually what we used. Elixir is a language that is quite kind of recent in the world of languages. But and to talk about Elixir means also to talk about its parent, because they are very related. So its parent is Erlang. And Erlang was started in the 80s. You really have this feeling of the 80s. It was started by Ericsson to solve their problems of communication, of telecom. So sometimes it's very interesting what they did, because they did to solving a different set of problems, so it evolved in a very different way. So sometimes it complements very well with other technologies. So they wanted it to solve their massive problem of telecom in Sweden, in Ericsson. And it was created mainly by this person, Joe Armstrong, which was also very interested in telecom problems, as you see. And it's not only a language, but it's also a virtual machine and a platform that go very well together. And who uses this thing? I mean, apart from Ericsson, who uses this? It's anyone like, with access. So it's used for building databases, like React or CouchDB. Distributed databases use this. Or in gaming, it's a very good use case. Or betting platforms tend to use this a lot. Or telecom, of course, because of Ericsson. And also message passing, like projects like RabbitMQ is written in Erlang, or WhatsApp is written in Erlang. And they describe the language as Erlang is a programming language and also a platform used to build massively scalable, so real-time systems with requirements on high availability. And they actually, I mean, well, you can write this, but actually, you feel like they deliver. Like they did actually what they wanted. Like you have all the tools you may dream of I don't know how to do this distributed thing. You normally have to find libraries. They like, no. Yeah, the language is perfectly prepared for this. Sir, this is for you. Then we have Elixir, which is kind of a usable layer on top of Elixir, of Erlang, which is kind of has a syntax that many people didn't like so much. So this is more modern syntax. Was done by a Ruby on Rails developer, famous Ruby on Rails developer. And for this reason, it has been perceived as kind of more scalable Ruby on Rails, which I think is kind of the wrong introduction for the language, because, of course, you can use it maybe to do more scalable Ruby on Rails, but some people take it as, what I was doing this in Ruby on Rails, so I will just translate this exactly to this new syntax, and it will be more scalable. Well, in this case, you kind of, I think, have a risk to miss the point, because Erlang has a lot of tools that are not what you are expecting when you come from this perspective. Like there is, for instance, one wonderful library that was done by the same authors of Erlang, which is called Open Telecom Platform. And this Open Telecom Platform has one problem, that it has this name, that if there are no people who say every time that it's awesome, and it's awesome, For instance, I will never use it because unless I have a telecom problem. But then you start reading about it, and you see that it has applications for lots and lots of problems, super interesting stuff. So in Erlang, processes are super cheap to make. You can have lots of processes, and you are supposed to have lots of processes communicating with each other. And Open Telecom Platform defines basically two behaviors, the most important ones, to define how these processes work. So you can have supervisors that take care of the children, like they have strategies for when a children crashes, only I let him die, I don't care about my kid, or I bring it back, or maybe I kill all my children, I slaughter all of them in a cruel way. That's something a supervisor is the job of the supervisor. And also you have gen servers that are kind of the workers, the ones that can do the work and can crash, and then the supervisor will bring them back or not. These gen servers, if you come from this Ruby on Rails perspective, this will look very alien, because it's like, yeah, I was not doing this in Ruby on Rails. So, but this is how Erlang applications look, or Elixir applications. So here, this supervisor, for instance, we can have a supervisor for all the games, and then we can have a lot of gen servers that will be kind of our reducers. They will store the state for every game. For instance, you can, on demand, give me one more game, and it will have subscribers to this state. And how do these gen servers look? So I think, in contrast of when you come from a Ruby on Rails perspective, expecting to find Ruby on Rails here, if you come from having used Redux, I think you will have a much better time dealing with this. Because when you are asked to implement a gen server, you are asked to implement some callbacks. And these callbacks have this shape. Init produces an initial version of the state. Okay? And then the process has a state. And then for subsequent calls, the process receives an action, a request, and the current version of the state, and are in charge of producing a new version of the state. So it can be used exactly as we were using reducers. So it will be the same, but still using all these supervisors and all the stuff we have for real-time communications, like WebSockets and so on. These gen servers can be used for other things because they don't have the requirement of being pure functions. You can do other stuff in there. They can have more applications, like a lot of things, but you can still think about them as reducers. So this applies. Like we have reducers, and we have the state is a consequence of the actions that we have received. So you can apply the same paradigm. So let's see how to re-implement this part, because the other part won't change. From the point of view of the frontend, it will be the same as using Redux. Let's see how to dispatch an event and then change the state, change our kind of reducer in Elixir. So we receive an event now from WebSockets. We are not using Socket.io, which is an Node.js library. We are just using a framework in Elixir called Phoenix, which has wonderful support for WebSockets. And here, it's the same idea. You are wiring, you have events, and you are going to dispatch actions, or you are going to call callbacks, which is the equivalence. Gameplay will be play, game reset, we reset. And then this is how the gen server will act. Always here will be the equivalence for reducers. So init, as we said, is to provide the initial state. And then, for instance, to do reset, we say when we receive reset, we have to produce a new version of the state that is the initial state. And before we are done, before returning, as we can do side effects here, we can broadcast it to everyone who is subscribed. So it will be equivalent to this. Or this other case, which again is not important unless you are super into tic-tac-toe. Okay, the exact syntax is not so important, but you can see a bit more of the syntax of Elixir, like this triangle operator is kind of a piping operator. I mean, kind of different, but still, at the end, it's the same idea. You are receiving a state, you're receiving a request or an action, and you need to process it and have a new version of the state and send it to everyone. And with this, we can have also the same feeling of stretching the frontend using kind of Redux. We are sending actions, immutable actions, and we are receiving a state every time. I hope you see kind of the equivalence, because we are not restricted to use this to one platform. Well, this was kind of code I put in some slides, but maybe I made it up. So let's do I push these examples into this repository, and then Node.js and Elixir. I will run the Elixir one. So I will start an interactive mode, this debugging mode for Elixir, so we can see what's going on. Like I'm listening to this port, so on, and then I'm starting the React application that will be connected to this backend. So yeah, I can play this random. Okay, I won. Yeah, even like this, I won. Yeah, I like this game because I won every time. Yeah. Okay, enough. So we said that the processes are super cheap. So because we are actually holding the memory for the state of a single game in one process, and if there is a new game, we'll have a new process. So how cheap are them? Can we have like 10, or can we have like 100? Or maybe can we try to crash this, or can we have like 1 million processes, 1 million games? So I will start this observer, which is also a debugging tool for seeing the virtual machine, how it works. Like now it has 254 processes, like for instance, just for handling. Yeah, this is a supervision tree at this moment with a lot of handlers for HTTP connections that may come. And we have this game supervisor, and I'm going to put here 1 million games if I don't crash this. I have these load charts that will show the memory usage. And then yeah, I can say, supervisor, please give me 1 million games. So I started 0 games, yeah, 100,000. You see that the memory will go up because we are basically producing new information. And the processes are more or less like, in this case, 3 kilobytes per process. So at the end, it will be like 3 gigabytes. This is not a real benchmark. I mean, my laptop is not really tuned for this kind of work. I have other applications and other stuff. And also, in a real benchmark, you should add like the actual WebSocket connections that are also processes in Erlang. So you have typically another processor to handle this. 800,000, OK. Also, this application, by the way, is stateful. So it's not stateless. But since the moment you have WebSocket connections, and this is part of your application, is part to know who is connected and who is not, then it will be stateful every time. So that's one of the reasons, for instance, we choose this platform, because it's really very great for this and has very good error handling for this kind of stuff. So has that, yeah, 1 million games in 48 seconds. And if you look at, yeah, here is 1,255,000, and I can still win this. It's responsive again as the beginning. So, well, I'm going to kill these processes because they won't die by themselves. And sometimes I do this kind of in a server, and then months later I come back and see all these processes that are waiting for me, and they are like for months waiting, and it's kind of creepy because they are not even zombies. They are like waiting. Let's play a game. So it's better to kill them when you can. So we saw that we can have like the same feeling of sending actions, receiving state, and having kind of reducers, even in a platform that is as different as Elixir, that was made even for a different problem. You can find always this kind of patterns. Then, now we have 1 million games. Can we, now that we have this, describe this solution as with different names, with different ideas? Can we, for instance, say that we have in-memory tic-tac-toe database, like we have 1 million cells of a database, and it's not crude, but it's only accepting vocabulary that is valid in tic-tac-toe, like movements that are valid. Well, we could put in our plan. We are writing a massive tic-tac-toe database. And I really, as much as I like this game, I will never use it, at least for me, because it will have a direct influence in the evolution of this project. It will, I mean, I like this, but if I start telling people we are building a database, they will start building the database, actually. And the focus will will change. And for instance, here, the detail that we are actually storing this in memory is irrelevant. We could actually call a database at the beginning, do a reducing operation, and store this into a DL database. But still, this will be kind of exotic way of thinking about this problem that will be valid and will have an impact. And let's see another one that maybe is more useful for some of you. Is this one. Can we think also about this as event sourcing? So event sourcing, it's a much general paradigm that used for many people. It goes like this. So a client sends events, so we produce events, and the server will store these events in a queue. So this is the real focus of event sourcing, to have a queue, a log, that it will be the source of truth, and we really let's do the best we can to have this queue of immutable events, which also might sound familiar, to have immutable events in a queue. And then we have to produce views of this state. So instead of replaying the log every time, we kind of have a read model that is ready for the queries we expect to receive from the client. So in this case, maybe the game is ready to be read. And then we can also have more views. This is more flexible. We could have, for instance, another view, so a user can check all his history in all the games of the platform. What I did, I answered this question, and then I played chess, and then I did this, everything. Different way of replaying the log. Or we can have maybe top scores or something like that. And then this is a paradigm that has been used in many, many cases, like in e-commerce, in logistics, in many cases. I think it's comparable to it's a major paradigm. So how is this similar to our solution? What do we need to make it really fit the solution? So we need to make two minor details. It's just going a bit step further in the requirements. This view must be the state we're going to just copy directly into the client, or maybe a diff, but not events, directly state. And then, in order to have the circular flow, there is an arrow that is slightly, well, it's not slightly, it's in the opposite direction. It's the queries. We are actually querying for something to happen. Has some change. We should flip this query arrow. So, and then subscribe to changes. Whenever there is a change, whenever someone manipulates this store or this state, we receive the changes. And with this, from the point of view of the front end, nothing will change. We still have events, kind of a reducer, and then we receive state. And we are using a a paradigm that has been used for many cases, not only my gaming case, which for me, my solution is simple for this, but maybe your case is best fitted with this. Then, so this will be, I promised at the beginning, I will talk about a very specific problem to showcase this, but in case you have another problem, maybe it will be a solution that can be extended to embrace your problem. That's it. But I think that this perspective of making this play the backend well together by these rules has a general interest apart from the particular implementation that we at the end choose. Okay? Because what I have seen many times in companies, it's pretty normal that, and it's natural that you have backend team and front-end team. Sometimes the focus is that the backend team has to produce the best, the perfect API, the best API possible, and then the front end, so the backend is doing this API level 3, level 4, hyperlinks. Our goal is to build the API. Our goal is to build an API, and then you have so now you have all the information you want front end to consume. It's ready for you. It's enough, should be enough. And then you have the front end, and its goal is to produce the best front end it can with this API. And I think it makes a lot of sense from the point of view of the management, because you have this clear boundary, and you see people here circles, and you say, I add one more here, I add one more here. From management perspective, it's wonderful. But maybe from an engineering perspective, sometimes it will be better to think globally and not have the goal of building the perfect API and the perfect front end for this API, but to build the best product we can, as a whole. So, and also, come on, I mean, we have been, at least for years, playing this game of CRUD, where we had this shape of the database. We happen to have this shape of the database, and so everything had the same shape, forever. Have resources, this whole for operations. Let's replicate this. Let's see how far can we go. Can we just, now we have different tools. We have different environments. Can we make the system play a different game? I think maybe it would be time to make the system play by different rules. I think this is worth this to try. Okay? Thank you.